Hello, welcome back to NMI. In this video we're gonna revisit the 386SX that we saw in the previous video, and the main reason was the comment from a viewer named Hugo. He mentioned that the performance of the machine, like playing Wolfenstein 3D, was not very good and that the game should play faster. So we're gonna take a look at how we can maybe improve the speed, and in the end I decided to perform a benchmarking on all, or not all, but some of my retro machines, and that's what we're gonna do in this video. As I mentioned in the opening, in my previous video we saw this 386 and I installed and played a little bit of Wolfenstein 3D, and one of the viewers, his name is Hugo, he commented that the game was too slow on this machine. It shouldn't be that slow, that maybe there was something wrong with my configurations. At first I thought that it was because this is a 386SX and the SX version is slower, right? Because it's a more affordable version of the DX. And also I want to apologize because in the previous video I mentioned that the difference between these two is the FPU, but that's not true. Back then no 386 had integrated FPU. That only started to happen on the 486. The difference between the DX and the SX was the data bus width. On this machine, on the SX, it's 16 bits wide, and on the DX, it's 32 bits wide, right? So this machine, the 386SX, is kind of a hybrid. It's 32 bits internally in the CPU, but it's externally it's 16 bits, right? It also has the smaller or shorter address bus. So on this processor, it's only 24 bits compared to 32 bits on the DX version. Anyway, this is a more affordable version, and I thought that was the reason why it was underperforming. But I decided to have a look, and this is what we're gonna do in this video. So the first thing, I'm gonna turn this machine on and we're gonna take a look at the BIOS, and I'm gonna tell you I already found the issue, and it's very silly. Let's go into the BIOS. The standard here, we don't have much to see, but in advanced also there's not much. The video shadowing is enabled, which is good. But here the first line is what I started to realize what was the problem. Low CPU clock speed divided by 2. What is the meaning of that? Well, these machines, they have this turbo switch. In my case now it's pressed, and that is the difference, right? So when turbo is pressed, the machine or the CPU runs at the fastest clock speed possible. In this case it's going to be 25 megahertz. When it's not pressed, then this setting here applies, and this is dividing the clock by 2. So that means that the machine when it's not we're not pressing turbo, it's gonna run at 12.5 megahertz. And I'm pretty sure that is how I was running the machine back then, right? So that is the reason why Wolfenstein 3D was so slow. So I'm not gonna change anything here. All the other settings, they look okay. All the wait states here are disabled. The machine is working without any added wait state, so I'm not gonna add one. um, we're gonna just go ahead and write this. I didn't have to write, but anyway. um, yeah, it's gonna boot up. We're gonna see that even Windows, wow, it's not pressed, right? I'm gonna press turbo. Windows is gonna load much faster now compared to the previous video. um, yeah, I'm gonna run. Let me exit. Now let's run Wolfenstein 3D. cd wolf 3D wolf 3D. It even loads faster here. Of course, it's double the clock speed, right? So here we can see, this is much faster. This is how it should be, right? I can use the mouse. Yeah, this is now playable. The way it was before, it was not playable. Okay. Oh, too far. Oh, okay. Oh, let's try something. Let's press turbo. And now we are not in turbo mode. Huh, interesting. Now I can't see the difference. That is odd. Oh, anyway, let's press turbo again. Let's exit this game. Now let's run a benchmark. I'm gonna use Topbench, which is a pretty cool and modern benchmarking tool that can run on older or very old machines. It can run from the 8088 up to a Pentium 4, so it's pretty cool. Let's go to drive B, cd Topbench, and Topbench. So it's loading the database with the machines that it knows. You can submit your own scores to the database. Oh, there is probably something wrong. now. Okay, it worked. Now we can go to benchmarking here and the real-time benchmarking. And here it is gonna measure the performance of the machine. There's a memory test, opcodes, video memory, 3D games benchmark. And you can see here we get a score of 31, and that puts us in the same level of a 386DX at 20 megahertz, right? Let's try now without turbo. Oh, see? Now the score is 21, and we are equivalent at 286 at 12 megahertz. That is the reason why Wolfenstein 3D was slow. Anyway, so let's keep it pressed. Now I'm gonna go here and add this system to the database. Well, first we're gonna run this score. Oh, there are some artifacts on the screen. That is not good. Let's exit. Even the cursor is in the wrong place, maybe? Let's try again. Topbench. No, yeah. There is something wrong with... It's the VGA card. Yeah, it's something with the video memory. Let's reboot the machine. You don't want to run this tool from Windows because the scheduler is gonna mess up with the score. We can try that. Now let's go directly to add this system here. Yeah, this is not an artifact, this is the mouse cursor. Okay, it's working now. So let's add skills XT 386SX. Steals that is just the case, right? So let's add clone 386SX. So this is a 386SX, 25 megahertz. That is BIOS. Description. Let's just add that this is a 386SX with 8-bit ISA VGA card, Lava computers. Okay, submitter. Wow. And okay, now we can just save the database, or you can just exit and say that, select yes, that you want to save the database, and it's saving. And that's it. Now we're gonna try other machines. Oh yeah, before we go, I want to show you something. Can we exit to Windows? No. C Windows. Win? Yeah. So I want to show you what happens when we run the benchmark from Windows. Because we can open a DOS prompt here, right? Let's see here, MS-DOS prompt. And we can go to drive B and run Topbench, right? Yeah, but let's see something. If we do a benchmark here, yeah, see how it oscillates. 30, then it goes to 19. That is because of the Windows scheduler, the operating system scheduler. So this is why I don't recommend, you know, running this benchmark from Windows, even inside the like on DOS there, right? So you need to exit Windows and then run the benchmark. Okay, that is it. Now let's do the same thing on another machine. Okay, let's benchmark the Tandy 1000 TX. This is a 286. It's almost a mix between a hybrid between the PC-XT and the PC-80. I have the benchmarking software on the floppy drive. So, yep, Topbench. Finally, we can go to benchmark. It's not. I think the color scheme is not very nice for a monochrome monitor, but we have selected benchmarking, and if we go to real-time benchmarking, oh, we can barely see anything. So it's running the benchmark score 14, and there is another Tandy 1000 TX in the database, and it's matching that machine, which is expected and pretty cool. So let's add this machine. Oh, now I can't see the cursor. Yeah, okay, database operations, add this system. System Tandy 1000 TX, CPU 286, 8 megahertz, BIOS unknown. Yeah, I'm gonna leave this. There's nothing special about this machine. It's the standard Tandy 1000 TX, so I'm not gonna add any description. Submitter Fabio NMI. Video adapter Tandy 1000. Yeah, it's the standard. It's a CGA. Okay. And now we can exit. It's gonna ask to save the database. Yes. It's gonna save, and we're gonna now move to the next machine. This is gonna take some time. The next machine is this 486 laptop, the Magitronic 7500. We saw this laptop in this channel some time ago. This is a 486 DX4 100 megahertz. So let's run the benchmark. The floppy is already in the drive. CD Topbench. Let's see what happened. Oh, it loaded so much faster. I could barely see it. Okay, benchmarking real time. Whoa, yeah, okay. This one is giving us 183, and it seems correct. The matched system is 486 DX4 100 megahertz. Awesome. IBM ThinkPad 755 CD. Yeah, okay. That's good. So let's add this system to the database. Magitronic 7500 laptop submitter Fabio NMI. Okay, and it's gonna save to the database now. Good, nothing to do. Let's go to the next one. Okay, the next machine is this 486 desktop. I'm still working. This is a work in progress. The heatsink here says Intel Overdrive DX2 PR66. So I want to believe that this is a 66 megahertz 486. Let's check it out. Let's go to drive A. CD Topbench. Okay, benchmarking 130. Okay, this is not very good. It is scoring as a 486 50 megahertz. That is interesting. Okay, you know what? Let's take a look at the BIOS configuration. Okay, let's take a look at the BIOS standard. Oh, we need to configure, yeah. There's something wrong with the battery. But I already have the hard disk here. This machine has this auto detect hard disk function, which is pretty useful. Here we have advanced numeric processor test enabled. Okay, system boot up, CPU speed high. Okay, that's important. We're gonna boot up in the highest speed. External cache enabled, internal cache enabled. Okay, advanced auto config function enabled. Okay, so can I change this? No, I can't. Okay, refresh cycle slow. Oh, that's not good. Slow is not good. Let's try first fast here and see what happens. What else we have here? Non-cacheable block 1 enable. No, this is disabled. Okay, this is good. Shadow. Okay. Yeah, let's try this. Save. I have a Windows 98 boot here, but it's not really good. I should replace it. It tries to find the CD-ROM, but the CD-ROM here is not working. It's an older CD-ROM that is connected to the sound card here, and it's not working properly. Okay, now we have drive C. Let's go to drive A. Oh, looks faster. Is it faster? Looks faster to me. But maybe it's... Well, no, it's not faster. Yeah, it's the same thing. Yeah. Okay, that didn't help, but it also didn't make it worse. So that's good, right? So the next step, let's go to the BIOS again and let's disable that auto config. Advanced. Now let's disable this cache read option 3222. What are the options? 3111, 2111. Let's try 3111. I'm not gonna change anything else because if you start changing a lot of things, you don't know what is that you're doing, right? Not that I know what I'm doing, but at least you can understand which change works and which change doesn't, right? So let's see. It doesn't look like it's working. No, it's stuck. So that one was not good. Oops, I was too slow. Yeah. Okay, now let's revert that change to 322. Let's try this cache write option, 0 wait state. It had 1 wait state and now has 0. Maybe this is, let's see, right? Yes. I can't even see the cache. Oh, I think they're right there. Let's see. Oh, okay. This looks promising. Oh, okay, it's booted up. Let's go to CD Topbench. Topbench. Is it faster? Now I don't trust my eyes. Benchmarking. Let's see. Oh, 139. Cool. So that made an improvement. Now Intel 486 DX2 at 66 megahertz. Okay, now we're talking. So that was a good change. We're gonna keep that one. Okay, let's try 139, right? Let's see. Let's try something else. I think there was another wait state there. Here, yeah. Oh, this is for the DRAM. Yeah, let's try 0 wait state. Worst can happen is that it doesn't work and then revert. Okay. Okay, it's promising. It's booting up. Oh, I like it. Benchmarking. Yeah, it didn't make any difference. The score is still 139, but apparently it works this way. So I'm gonna keep this setting. Let's go back DRAM type fast page mode. I think I'm gonna keep it fast page. Keyboard clock, I don't think that is gonna make a lot of difference. AT clock select. I think this is for when you are not in turbo mode, right? Let's try clock divided by 2 just in case. Coprocessor ready. Let's... oh, but I am changing multiple stuff now. Yeah, okay, let's try this one. AT clock divided by 2 here. Oh, 159. That is much better. Okay, now that is much better. And if we press turbo, 46. Oh no. Okay, and without turbo, 159. Okay, we're gonna keep that one. That is very good. It is interesting that it still matches a 486, but the score is much higher. And it's also interesting that this 486 has a score of 170. We are at 159. So that tells me that we still have space for improvement. Oh, but that machine has a lot of goodies. 16 megs of RAM, and apparently Diamond Stealth, not Slath, a Diamond Stealth 3D 2000, which is it was a nice video card back then. Yeah, okay. So let's try something else. So we're keeping that option, that configuration. And I/O recovery. Oh, lots of options. Oh, I think I'm gonna keep this one like this. Refresh, hold PD buzz. I am not sure what is this. I'm gonna try this coprocessor to no delay. And that's the last thing I'm gonna try, honestly, because it's too much. Maybe the other system has, you know, faster memory or something. Yeah, because like of that. Right to CMOS, yes. Yeah, you can see that we are working with the slowest configuration for the cache, right? And oh, sorry. Okay, real-time benchmarking. 159, yeah, still no improvement. Well, that's it for this machine. I'm not gonna... so now what I'm gonna do, let's save this score. $486. $66 megahertz, apparently, right? Intel for DX2, 66, yeah. Description, Intel overdrive DX2PR66 submitter NMI. Okay, and exit and save. Now we're gonna do one last machine. My HP Pavilion, which is a Pentium 233 MMX. Okay, the next machine is the Pavilion. This is a Pentium 233 MMX. I was too lazy to move it to the other place for like testing there, so I decided to move the camera here instead. Let's run Topbench. Yeah, the performance could be better. What is that? 100 megahertz. Yeah, I don't like this. Let's see if we can take a look at the BIOS. Okay. This has 32 megabytes of RAM. PCI configuration. Cache RAM 0K. Yeah, there's not much we can do here. No, I don't want this. Yeah, this is just configuration. Yeah, there's not much we can do. Oh, power savings customized. Maximum performance. Maybe this is gonna... No, I don't think so. But let's try it. Exit saving changes. No. No improvement. That is interesting. That is something for me to research. The performance of this machine is... Oh, but look. Maybe it's because... But the score is very stable. But the total time here oscillates a lot. 190 something up to 200. Well, that's it. I'm gonna add this machine, but you don't need to watch me typing anything.
Before we go, I want to show you something. After I recorded this video, I decided to have another look at the 486. As I mentioned, well, I didn't mention that, but one of the reasons it is a work in progress is I noticed that the CMOS configurations are not kept once I power off the machine. And I decided to investigate that a little bit deeper and understand why that was happening. And I found that, so this is where I replaced the battery. I added this diode here, right? This Schottky diode. And underneath the board on the bottom side, there is a track connecting the diode here, or the positive side of the battery, to this via. And then there is this track connecting that to this resistor, and so on. What I found was that this track is interrupted here, right? So when the battery leaked, it corroded this track. So that's why the battery, the CMOS configuration are not kept. It was working. It works when the machine is powered on, because there is probably some stray capacitance or somewhere in the circuit. I didn't check, but that is enough for you to for the system to keep the configuration when you power off and then back on for just like a small amount of time. But if you powered it off for longer time, then the configuration is lost. So what I ended up doing was this. I connected this wire, this jumper wire, directly from the diode there to the resistor, and now everything is working as it should. And probably this 486 is not going to be a work in progress anymore. Well, not on the hardware side. I still need to install software and get the drivers for the CD-ROM, but that's another story. That's it for this video. I hope you really enjoyed this content. For sure I enjoyed benchmarking and comparing these machines. And so if you enjoyed this video, please like it, give me a thumbs up, and subscribe to my channel, and see you next time. Bye.